Now let's look at a final few functions that are really, really useful on any distribution. So these are the functions that you often talk about when you talk about a distribution in general. And Python can give us these as well. Up until now, we've been looking at just functions that do kind of things with the distribution and not about the distribution. So here are a number of functions that talk about the distribution. So given any distribution we've loaded into variable d, we can use any of the following functions provided by the scipy.stats library. The first function is we can find the expected value of the distribution. So what's another word for the expected value?
The expected value is also known as the mean of a random variable.
Yes, and that's exactly what we do here. So we can say d.mean, and that's going to give us the mean of the distribution or the expected value.
Perfect.
So the other thing we can get is we can also get the 50th percentile of the distribution by saying d.ppf of 0.5, like what is the 50th percentile, or we can say d.median. So d.median finds the median of the distribution. And we can also find the standard deviation of a distribution by doing d.std. So every distribution has its standard deviation defined on it. So let's go ahead and find these properties of some distributions we've been working with so far. So we've been working with the normal distribution. So if we go from scipy.stats, import norm, we can import the normal distribution to use. And then we can say d is equal to norm to load in the normal distribution into our variable d. And then we can say d.mean. And that should give us the mean of the standard normal curve. And we know, because it's a standard normal curve, this curve has to have a mean of 0 and a standard deviation of 1. But let's see if Python really tells us that it's true.
I just ran d.norm, and then I can do d.mean.
d.mean.
And I get 0.
You get 0. The mean of the normal curve is 0. That seems great. What about median? The median value, the center value of the normal distribution.
d.median is also 0.
Should be 0, and that's true for the standard normal distribution, right?
Yep, right in the middle.
And what's the standard deviation of a standard normal curve?
It should be 1.
Should be 1. Let's see what Python says.
Python says 1.0.
Perfect. So we see that this matches exactly everything that you've taught our learners, and this works great.
That looks awesome.
So let's look at a discrete distribution. Let's look at first a Bernoulli distribution. Again, thinking about that bag where we have 3 blue marbles and 1 red marble, and we want the probability of drawing that red marble. So we have a Bernoulli distribution with a success rate of 0.25. So once we created this distribution and imported it from the scipy.stats library, we can ask what is the mean of that distribution?
And it is 0.25.
0.25. So the mean of the distribution is 0.25. And that makes sense because we have 1 at 25% probability and 0 at 75% probability. So that average is 0.25.
Yes.
What about the median point? So this is interesting. What would be the 50th percentile of this distribution, Carly?
So that would be 0, actually.
Yeah, because we have to, the bottom 75 percentile is all 0. Is that what Python says as well?
Yep, that is what Python says.
And then the standard deviation. So standard deviation, Python or Carly worked through some of these with us, but often if we want to skip over the math and just see what the standard deviation of it is, we can just ask Python d.std.
And we get 0.433.
0.433. So the standard deviation of this distribution is 0.433. This works for any distribution that we have in Python. So to just finish this off, let's look at a binomial distribution. So here we have our classic exam with 5 questions, and for each question there's 4 possible answers. And the chance of us getting an answer correct is 25% because there's 1 option out of 4. And this is going to create a binomial distribution that's going to tell us how many answers we got correct on the exam. So if we do d.mean, this is going to tell us the mean of this distribution. What's the expected value of our score on this exam?
So it is 1.25.
1.25. And that makes sense because Carly taught us that the mean is n times p, or 5 times 0.25.
Exactly.
And then the median of the distribution is going to be what the 50th percentile point is on this distribution. So if you go ahead and do d.median, what do we see?
I get 1.0.
1.0. So 50% of the students get a 0 or 1, and 50% of the students get a 1 or higher. And then let's see the standard deviation of this distribution. I think, Carly, you said that was a square root of n times p times 1 minus p?
Exactly. And I end up getting 0.968.
968. So we could have done the math of doing n times p times 1 minus p and taking the square root of that, or we can just do d.std, and that gives us the exact same answer of 0.968.
This is so convenient.
I really like it, and I love kind of thinking about things as distributions, because all of these things, we can imagine any event that has a single fixed probability replayed multiple times. It doesn't matter if it's rolling dice, flipping cards, flipping coins, taking exams, or anything else we do, that we can model them by using the same distribution no matter what the real world event is. So this is what data science is all about. It's understanding statistics and understanding how we can use Python to make our lives really easy so we can model really, really complicated problems. And we can nerd out with a lot of data and find a lot of insights by just working with Python while knowing some statistics.